Hello everybody, I'm making this video as a follow-up to my original prompt about these three types of questions. Okay, now I want to expand a little bit on what I said in the original video, but here goes. There are many rules that involve exponents, and I'm not going to talk about all of them right now, but regarding our discussion that I've started, exponents will distribute over multiplication and division. So in other words, if I have the quantity 4 times x raised to the third power, then in that case the exponent distributes to each factor. Okay, because that's multiplication in there, that says 4 times x, and exponents distribute over multiplication. Okay, so you'll get 4 to the third power, which is 64, and x to the third power, which is x to the third power. We could apply the same thing with this one. This one says x squared, then times y to the third power, and we're taking that entire quantity to the fourth power. That's what these parentheses mean, right? So the exponent still distributes, but we have another issue going on here that I'll mention, that here we're taking something that's raised to a power and we're raising it to another power. Okay, so what happens if you have, say, x squared? So you've got this number x, and it's raised to the second power. And then you raise that, whatever that is, the fourth power. What can you say about that? Well, when you take a power and raise it to a subsequent power, you multiply them together. Okay, so that's our rule for raising a power to a power. So 2 times 4 is 8, so that makes it x to the 8th, and it distributes over here, y to the 3rd, then to the 4th. That'll be y to the 12th, okay? So exponents distribute over multiplication. That's multiplication, and this is multiplication. And exponents distribute over division too. So look at this last one right here. I have, I guess, a little bit of everything. I've got 4 times x on top, so that's multiplication, but then that's divided by y squared. So this 3 applies to that because exponents distribute over division. But it also applies to this down here, okay? But that 4 times x is multiplication. So, all right, the 3 gets applied to the 4x. That's 4 times x, so that'll be 64x to the third power. All right, and then down here, the y squared also gets to the third power, but we said when you take something and raise it to a power and then a subsequent power, you multiply them together, so that amounts to being y to the 6th. Okay, so exponents will distribute over multiplication and division anytime you see multiplication and division, all right? Exponents will not distribute over addition and subtraction. It never works, okay? So like we cannot say 4 plus x and have that quantity raised to the third power be 64 plus x to the third. We cannot distribute the exponents. It's not correct, all right? That's addition. Can't distribute exponents over addition. We can't distribute exponents over subtraction either, okay? So here in this one, I can't say that what this means is x to the third, then to the second power, and then 2 to the second power, all right? Because, like I said, exponents will not distribute over addition and subtraction. Now the parentheses say like this entire thing gets that exponent. What if this didn't have the parentheses? What if it just said 4 plus x to the third power? You know, what if I erased that parentheses? Then like there would be an issue. Like it's just the x that has the exponent. 4 has nothing to do with it. All right. So that's the role the parentheses play there, and that's why I'm using this as an example to tell you that exponents do not distribute over addition or subtraction. Okay, so here's where this leads us though. If these are incorrect, if you can't do that, then how can they be solved? Okay, so let me give you 3 answers to that. How can we solve these? Now, here I have these same 2 problems here that I illustrated weren't right, okay, because exponents don't distribute over addition or subtraction. But how can we solve them? Or how can we take x to the third minus 2 and square it? Or how can we take 4 plus x and raise that to the third power? So I'll give you 3 answers. My first answer is, who cares? Just leave them alone. Why does it matter? Can't you just leave this the way that it is? Yeah, sometimes, yeah. I mean, it's not like it's sitting there and you have to do something to it. So this might seem like a joke, but I'm being serious. Like it might not matter, okay? And maybe like depending on what the bigger context is, like whatever you're doing in math, maybe you can just leave them alone and it'll be fine. And then there's nothing to worry about, okay? But that's not always the case. My second answer is you could use a computer algebra system, okay? In our class, I don't want you doing this all the time because our curriculum doesn't involve you having a computer do all the work for you. Okay, that's just the way that it is. But it would be bad if I didn't mention this, or if I didn't say that you could do this some of the time. All right. So here's one I like, wolframalpha.com. There are lots of computer algebra systems online. Sometimes handheld calculators have a computer algebra system in them, but what it means is if I want to know what x to the third minus 2 squared is, then I can type in here like x to the third minus 2, and then I want to square it, and so here's the syntax. That's the way I would type it in, and I press enter, and it might tell me all kinds of things about it. All right, it gives me the graph and so on, but there's what it expands to. All right, as we would multiply it out, x to the 6th power minus 4x to the third plus 4. Okay, so in that sense, yeah, I could do that. I mean, it's generally okay. I'll assume that, say on a test, if I ask you to show your work or something like that, that you are not using a computer algebra system and that you know how to work things out. Okay, now I haven't addressed how we would solve this yet, but I'm about to. So what was it? X to the 6th power minus 4x third plus 4. Okay, so it would be bad if I did not mention the role that technology plays in doing all kinds of math. Okay, so you could use a computer algebra system. Now, I would be a little unsettled if all somebody knew how to do was type things in to a computer algebra system or a calculator, and they had no idea what was going on behind the scenes. That would make me a little bit nervous if this was somebody in a STEM field that was really supposed to know what they're doing. So I don't want you to go crazy with the computer algebra systems and have that do everything, all right? So you can use this, all right, as long as it's not something that you're submitting your work on for a test. So my third answer is, here's how we would work things out, okay? All right, if I want to take x to the third minus 2 and square it, what does the word square mean in this context? If I square something, that means I multiply it by itself. So I take x to the third minus 2 times x to the third minus 2, okay? And those are two binomials, two expressions with two terms each, and the method for multiplying that is FOIL. We multiply the first, the outside, the inside, and the last, and it looks like that. Okay, so I take x to the third times x to the third, x to the third times negative 2, and so on. One rule about exponents I haven't talked about in this video is what happens when we multiply like things. Like, what if I had x to the power a times x to the power b? So here I'm multiplying the same thing together in x, but it has different exponents, let's say, or they each have an exponent. What do you do then? Well, when you multiply like things together, you add the exponents. Okay, so this will be x to the power a plus b. So that's why here x to the third times x to the third, well, 3 plus 3 is 6, x to the 6th power. Okay, all right, now I simplify all that. That's what the FOIL looks like. And my final answer is here in the box. It's the same thing that the computer algebra system gave me, but, you know, like I said, I would be nervous if that's all somebody knew how to do was type stuff into the computer. Plus, like, it's not the curriculum for our class to do that. So I'm going to insist that you know how to work things out on paper, like you're seeing right here. What about this other one, 4 plus x to the third power? Well, what does the third power mean? What does it mean to raise something to the third power? It means you multiply it by itself 3 times. So I've written that out right there. 4 plus x times 4 plus x times 4 plus x. Now, because these are binomials like that and this, we can use FOIL for that. So 4 plus x times 4 plus x by FOIL is 16 plus 8x plus x squared. And then I still have this one. So I'm multiplying these things with something called the associative property. So it's kind of like, what is 2 times 3 times 4? How would you do that? Well, I mean, I guess you could do one thing at a time. Like, you know, 2 times 3, that's 6, right? Okay, so what we got here is 6 times 4. And now 6 times 4, well, that's 24. So that's sort of what I'm doing here. I multiply these first two together. Okay, I got that. And then still I've got this one. How's that happen? So in this case, with that having 3 terms and this having 2, then what we do is it's just like everything has to get multiplied together. Okay, so this 4 has got to multiply all that stuff. All right, additionally, this x has got to multiply all that stuff too. And if you look at what I've written below it, that's what you'll see. Multiplying the 4 times each of these, multiplying the x times each of these. And then I add like things together. And I put things in a certain order. X to the third power, that's got the biggest exponent. What's like? What kind of things are the same that can be added together? Well, here I've got 4x squared, and there I've got 8x squares. How many x squares does that make? 8, 4, that's 12x squares. Here I've got 32 x's, and there I've got 16 x's. Well, how many x's do you have all together? Oh, so 32 here, 16, that's 48 x's, and then 64. So that's called adding like terms, okay? All right, so those are my 3 answers. 1, who cares? Leave it alone. Sometimes that's all right. 2, use a computer algebra system. You should at least know that stuff's out there. And 3, I must insist by the curriculum of our class that you know how to work things out on paper too, okay? All right, now how about this? Let's close this by like, do you want to think philosophically? Let's do that real quick. Some people are prone to philosophical thinking, and here I've got a cartoon Einstein, and he's wondering like, what really makes this correct and this incorrect? I mean, really, like, because I don't see anything up here besides me telling you it's incorrect that actually shows that it's wrong. I mean, because some people would think that that looks right. All right, so, like, what really makes these right or wrong? Well, I'll mention to you this way. And you might lose this perspective when you take college math classes, but math is about numbers, okay? You know, algebra is about numbers. Algebra is math. And so when we put x's and y's and z's and we put letters everywhere, well, at the end of the day, then those are going to be numbers. So math is about numbers. So what makes these correct or not, really, is that a correct statement would be true for all allowed substitutions of the variable. So what we're saying is, this one being correct means that if I put different values for the x, then this statement will be true. And this one being incorrect means if I put different values for the x, then this one would be false. Okay? Maybe not all the time, but it would be false enough of the time that I can't rely on this being a correct way to go about things. So let me show you that. So I'm going to take these 2 statements, and I'll take a number. Let's take 2. 2 is a simple number. You can pick another number if you want to. All right? So I take this statement, I put a 2 in. Okay, I'm wondering, is 4 times x to the third power going to be the same as 64x to the third? Okay, so I put 2 in, and I work out each side independently. So 4 times 2, that's 8, and then 8 to the third power is 512. Over here, I put the 2 in, so 2 to the third power, that's 8, then 64 times 8 is 512. It's true, right? Even though these look different, when you put a number in, you get the same answer. That's what we're saying. When we say this is correct, that's what we mean. When I say that you can distribute exponents over multiplication and division, I mean that if you do that, you'll get something that once the numbers go in will be true. Now, this other one, which I said was incorrect, is I'll take 2. You can take 2 or 3 or 4, whatever number you want. But I put 2 in. I work out both sides independently, and I see if they agree. So I put 2, so 4 plus 2, that's 6. 6 to the third power is 2, 16. What do I get on the other side when I put 2 in? Here I put 2, I get 8. 64 plus 8, that's 7. That's not true, right? That's what I was saying. So that's what it really means, like to think philosophically about this. Okay? Where I think it's worth knowing that. When I say that anything in our class that involves letters, X's and Y's and Z's is right or wrong, it's got to come down to numbers. Okay, so for now, let's leave it with this. Exponents distribute over multiplication and division all the time, anytime, and exponents will not distribute over addition or subtraction.